Welcome to this lecture on the general rules of probability. The first rule we will consider is the general multiplication rule, and this rule applies to any events. The events do not need to be independent. The probability that A and B occur is equal to the probability that A occurs multiplied by the probability of B given that A has occurred. The probability of B given that A has occurred is the conditional probability of B given that A has occurred. An example of the general multiplication rule. L represents the event that a letter drawn at random from the alphabet is from the latter half of the alphabet, while V denotes the event that the letter drawn at random from the alphabet is a vowel. The probability of L and V is the probability of L times the probability of V given L. The probability of L is 13 over 26, since 13 letters are in the latter half of the alphabet. The probability of V given L is 2 over 13, since in the latter half of the alphabet there are two vowels. So given that a letter has arisen from the second half of the alphabet, the probability of a vowel occurring is 2 over 13. We multiply these two probabilities and we get 1 over 13, which is the result. The next rule we consider is the general addition rule. Again, this rule applies to any events. The events do not need to be mutually exclusive. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. An example of this rule is, let's say that we roll a die and F denotes a number smaller than 5 occurs, and the probability of F is 4 over 6. E denotes the event that an even number arises, and of course the probability of E is 3 over 6. The probability of F or E is the probability of F plus the probability of E minus the probability of F and E, which is 4 6 plus 3 6 minus 2 6, giving us an answer of 5 6. It was, of course, necessary to subtract the 2 6 because there are numbers that are both even numbers and smaller than 5. So when we add the first two quantities, 4 6 and 3 6, we have included these numbers twice, and so we need to subtract 2 6 to give the answer. Another general rule is De Morgan's rule. De Morgan's rule allows us to replace an expression with an alternative equivalent expression, and this can be useful. For example, let's say we have an expression involving the word or, and we wish to replace it with an expression involving the word and. This could be convenient if we are dealing, for example, with independent events, and the word and would be more convenient than the word or. De Morgan's rule states that we can replace an expression with an equivalent expression by performing these three steps. First, write not before the entire expression. Secondly, write not before each event in the expression. And thirdly, replace every and with or and every or with and. An example of this is that the expression A or B is equivalent to not A, and not B. We have applied the rules by putting a not in front of the expression on the right hand side, by putting a not in front of each event in the expression, and replacing the word or with the word and. If you like to think of it this way, on the left of the equivalent sign we have A or B, which means either A or B. On the right of the equivalence symbol we have not A and not B, which is another way of saying not neither. Sometimes the number of ways of arranging things is of interest in calculating a probability. The number of ways of arranging n things in order is n factorial, which we write as n followed by an exclamation mark. For example, in how many different ways can the letters A, B and C be arranged? There are 3 letters, so the answer is 3 factorial, which is calculated as 3 times 2 times 1, which is 6. Since there are 3 letters that can be selected for the first position, after which there are 2 letters that can be selected for the second position, after which there is just one letter remaining for the third position. A permutation deals with the number of ways of arranging R things taken from among n things, and it's denoted as n permutation R, written superscript n, capital P, subscript R. For example, let's say a 7-horse race has a result, and the result consists of the names in order of the first 3 horses. So 3 items are selected from 7 items and presented in a particular order. So the result, 7p3, is arrange all 7 things, 7 factorial, but then divide by the remaining 4, because 7 minus 3 positions do not matter, giving us 7 times 6 times 5, which is 210. And all of these quantities can be calculated quite simply using the appropriate key on a statistical calculator. A combination consists of a number of sets of R things that can be taken from among n things. So there is no arrangement, there is no order here, it's just a set of things that is taken. This is called n combination R, written NCR, in the way that a lottery player might select numbers, 6 numbers from a set of 47 numbers. It doesn't matter in which order the person selects the numbers, provided they select the particular winning set. So 47C6 is 47 factorial divided by 6 factorial divided by 41 factorial. And the result there is 10,737,573. You can read more about this in the textbook in section 2b.